So for this section, we're going to talk about the different ways that we can do operations with functions. We're going to talk about something called composition of functions, and then we'll also get into how you can add and subtract, multiply, and divide these different types of functions as well. The first operation I want to go over with you guys is that word composition. Okay, the composition of two functions basically means that you take one of the functions and you plug it into the other one. So the functions are going to be noted with like f of x, g of x, h of x. They're going to use those different letters to tell you like you've got 2 or 3 separate functions that you're working with in a problem. And how it looks like when you're talking about compositions, they're written one of two ways. It either looks like this, where you've got like f and a little open circle in between f and g. That little open circle is pronounced of in the math world. So this would be like f of g. And the other way that we write it looks like this, where you have f, and instead of the parentheses x next to the f, you have the g of x in that parentheses set. And it means the same thing. So like I said, when I say this, I'm going to say like f of g, or g of f, or f of h, whatever my functions might be. So let's take a look at an example here. We're doing these two functions here. We have f of x equals 2x plus 3, so there's the first one, and g of x is 4x minus 1. So these are the two functions that we're going to work with for these first couple of problems here. So the first one wants us to do f of g, but at g we're evaluating it at 0. So I'm going to break this apart into 2 steps. I'm going to first just focus on the piece on the inside, the g of 0. So this is what we saw yesterday when we were evaluating piecewise functions at specific numbers. You take that 0 and you put it into g's function. So you put it in for x and you evaluate it. So g's function is at 4x minus 1. So we're going to take 4 times 0 and subtract 1. So 4 times 0 would be 0, minus 1 would be negative 1. So the second thing that we're going to do now is we're going to take this negative 1 value and we're going to put that in for f. Because what the problem wanted me to do was to take g, evaluated at 0, and put it into f's function. Well, I did the g at 0 first, and I got negative 1. So now I'm going to take negative 1 and put it in for f's function. So f's function is 2x plus 3. So we're going to take 2 times negative 1, putting in that negative 1 for x, and then adding 3. So 2 times negative 1 would be negative 2, and then plus 3 would be 1. And this is my final answer here. Let's skip down to number 3. Number 3 says g of f at negative 2. So they have flipped the way that I'm doing my composition. For 3, I need to, similar to what I did to number 1, I need to evaluate the piece in the middle first, so that f at negative 2. So I'm going to take negative 2, I'm going to put that in for f function first. So that's going to be 2 times negative 2 plus 3. 2 times negative 2 would be negative 4. And then I add 3 to that, and I get negative 1. So now since I'm doing g of this, now I'm going to take that negative 1 value like I did up here on number 1, but I'm going to plug it into g's function now, because this has just got it reversed for us. Instead of doing f of g, we're doing g of f. We're just switching the order that we operate. So now I'm going to do negative 1, put that into g's function. So g is 4x, so 4 times negative 1 minus 1. So 4 times negative 1 would be negative 4. And then we subtract 1, so we're going to be at negative 5. Okay, so you guys take a minute and do 2 and do 4. All right, so for number 2, I got a final answer of 33. And for number 4, I got a final answer of 11. And I wrote out the work that you should have had there. So you plug in for 2, you plug in 4 into G's function first. You get 15, you plug that into F's function to get 33. And then for 4, you plug in 0 into F's function first, that gets you a 3. And then you plug it into G's function, and that gets you 11. So we're going to take this a step further now. For these next 3 here, they're going to give us 3 different functions. Okay, so we have an f of x, we have a g of x, and we have an h of x. So if we take a look at one, you just got to read what letters you're working with so that you know what function to go into. So one says we're doing f of h. So h is at -4, so I need to evaluate h's function first. So h of -4, we're going to put 2 times -4 minus 5. So that's going to be -8 minus 5, which comes out to be -13. So then I go back to f's function. So I'm going to take -13 and go back into f. And f's function says x plus 1. So we're going to do -13 plus 1, which is going to be -12. Okay, you guys try number 2, and then if you are wanting to try number 3, you can. Number 3 is a little bit more of a challenge because you have to do 3 different functions. So for number 2, I got 81. Now number 3, I'm going to do this 3 separate times. So I'm going to start with the smallest one first, like the one inside all of those parentheses first. So that would be h of 0. We're going to take 0, put it into h's function. So we're going to take 2 times 0 minus 5. That's going to be 0 minus 5, which is -5. Now, the next one that h is inside of is g. So I'm just kind of going from the inside and working my way out. So I had h, I'm going now to g, and I'm evaluating g at that -5 that I found when I did h of 0. So g is x squared, so we're going to do -5 squared, which comes out to be a positive 25. Remember, anytime you square a negative number, it becomes positive, because negatives times negatives is positives. And then last step is to go all the way back to f. So you take that 25 and you put it into f's function. So f's function is x plus 1. So we're going to do 25 plus 1, which is 26. And that's our final answer there. So it works the same way, even if they had 4 functions, 5 functions, however many. Most of the time, the most that you're going to see is 3. Okay, but it works the same way. Start with the smallest, like the innermost piece first, inside all of those parentheses, and then gradually work your way out. All right, if we go to the next page, we're going to be doing similar problems here, except they're not giving us numbers to evaluate it at. So they're going to keep this in general x terms. So I'm going to show you how you work with these, because it's a little bit different than, I mean, the way that we set them up is the same, but the way we evaluate is going to look different because we don't have a number that we're putting in. So we're not going to get like 5 or 10 for an answer. We're going to have an expression. We're going to have something with x's still. So we have 3 functions again up here. We have f of x, g of x, and h of x. So we just got to make sure that we watch the letters that they want us to use. So number 1 wants us to do f of g of x. So that means in this case, because I don't have numbers that I'm evaluating with, they want me to take g's function in terms of x and put it into f's function. So let's start by just figuring out what that looks like. So g's function is x squared, because it says g of x equals x squared up above. So what this means I'm doing is I'm taking that x squared and I'm evaluating my f function at that point. So anywhere inside of f's function where you see an x, you're going to have to replace that with an x squared. So f's function says 2x plus 3. So instead of saying 2x, in for x now we're going to put x squared, and then we still have plus 3. To simplify this, you're just going to kind of rewrite it so it says 2x squared, because it's like, think about distributing a little bit here, but there's really only one term to multiply into. So the final answer is going to say 2x squared plus 3. So let's take a look at number 2. 2 says g of h of x. So first, let's figure out what h's function is. So h is at 3x minus 4. So that means that we're evaluating g at 3x minus 4. So g's function is an x squared. So in for that x, I'm going to have to put 3x minus 4, that whole quantity. But since g is x squared, I'm going to have to square that quantity. So this is supposed to say g is supposed to say x squared. So what we're replacing x with is that 3x minus 4. And then we have to square this. So remember, 3x minus 4 squared means that you're taking 3x minus 4 times 3x minus 4. Okay, so you can FOIL this, or you can do the shortcut that we've talked about in the past with these when they're the same binomial twice. You can do the first term squared, so 3x squared, which would be 9x squared. Then you multiply the two terms, so 3x and the minus 4, and then you double it. So 3x and the negative 4 would be negative 12, doubled would be negative 24. So that's the middle term, so negative 24x. And then you square the last term. So negative 4 times negative 4 would be positive 16. And this would be our final answer. So you can see these work a little differently just because you're putting in x's for other x's and then you're having to evaluate. Now I would say most of the time, the most work that you're going to see here is when you start seeing x squareds and those kind of things. You'll see in some problems like an x to the third, x to the fourth, but I would say for the most part, for this class, we're going to keep it just at x squared, because otherwise you start getting really, really big answers. So why don't you guys try to do number 3. You're doing f of h. They just have it written differently than they do up here. This is the same thing as this. Okay, they just wrote it in the other way that we can write composition. So I want you guys to try this. Take h's function and plug it into f's function. So h's function is that 3x minus 4. So that's what we're putting in for f. So f is 2x plus 3. So 2 times 3x minus 4. So you put that in for x. And then plus 3. Now you have to distribute because you've got 2 times that quantity. So that's how I got 6x minus 8 here. And then I just combined the negative 8 and the positive 3 to get my negative 5. So I just added like terms together. So number 4 says f of x. This means that we're taking f's function and we're putting it into itself. So f's function is this 2x plus 3. So we're putting 2x plus 3 in for the x that we see there. So that function, we're going to do 2 times 2x plus 3. And then you still have plus 3. Okay, because I took that whole quantity, 2x plus 3, and I put it in for just the x in itself. So again, I'm going to have to distribute. Take 2 times 2x, 2 times 3. That gives me 4x plus 6 plus 3. And then we combine like terms, so it's going to say 4x plus 9. I'm going to give you guys a couple minutes to try to do 5 and 6 on this page. Now 5, again, has the 3 functions, so you're going to have to just break it into smaller pieces. You're taking g's and you're putting it into h's, evaluate that first, and then plug that into f and evaluate. 6 is back to like what we did on like 4, 3, 2, and 1. You're just doing g of f. So I'll give you a couple minutes. I want you to try to do those. All right. So for 5, I did g into h first. So I'm putting x squared into the x there. That got me 3x squared minus 2. And then I take that and I plug it into f. So I had to distribute, and then I combine like terms. So I ended with 6x squared minus 5. For 6, I'm putting f's function into g. And g is that x squared, so I have to square that quantity again. So this works just like number 2 did, where you have to, think about 2x plus 3 times 2x plus 3. So FOIL it, or use those shortcut rules again. Square the first term, multiply the terms, double it, and then square the last term to get 4x squared plus 12x plus 9. All right, if we turn the page, the last thing that I'm going to talk about with you guys today is adding, subtracting, multiplying, and dividing these functions. When you're adding and subtracting functions like this, you're just combining like terms. So you're looking at whatever functions it is that they want you to try to put together, and you're just adding any terms that they have in common. So x's, x squareds, numbers, anything like that. For multiplying and for dividing, you'll probably have to use like your distributive properties. So use your arrows, you'll have to FOIL. Use your box method that you guys learned when we were multiplying polynomials a couple chapters ago. And then for dividing, you'll have to think about factoring again. And if there's any way you can factor and then simplify expressions, kind of like what we were doing when we were working with all of those rational expressions where we would factor the numerators and the denominators and see if there's anything that we could cancel out. It's very similar to that. So again, I have 3 functions that I'm given up here, f of x, g of x, and h of x. The first one just wants me to add f and h. So f's function is 5x minus 1. And then h is x minus 3. So I'm just going to add these together. So I'm just putting a plus sign in the middle. And then I just look for like terms. So 5x and x can go together. So that would give me 6x. And then -1 and -3 go together. So that would give me -4. So my answer would be 6x minus 4. For subtracting, what I would suggest you guys do is write it out and put the functions inside of parentheses, because with the minus sign, that minus sign is going to have to get distributed over to the second function, because it's going to change the signs of those things. So f of x is that 5x minus 1, and then minus, we're subtracting g's function, which is x squared minus 6x plus 9. Now you don't have to do this, but I recommend this so that you can think about, okay, if I take this negative and I distribute to the inside of that second parenthesis there, it's going to change all of those signs. And the biggest mistake that I see happen here is that kids forget that, and then they end up just adding the terms together, and they get the wrong number, they get the wrong sign. So this becomes 5x minus 1 minus x squared plus 6x minus 9. So all of those second terms changed signs. So now if I look for like terms, negative x squared is kind of all by itself, so there's nothing for it to combine with. Now 5x and 6x, those can go together, so that becomes 11x. And then the numbers, you've got -1 and -9. Those are the last 2 pieces that can go together, so that becomes -10. So that's our answer for that one. The last 2 here show you multiplication and division. So 3 wants us to take g times h. So g is x squared minus 6x plus 9. And we're taking that times h, which is x minus 3. So this is when I said you can either use like the distributive property, or you can set up your box method, if you guys remember doing that. So multiply. You're taking x times all of those terms, and then you're taking -3 times all of those terms. So x times x squared, that becomes x to the third. Then x times -6x would be -6x squared. X times 9 would be 9x. Now I'm going to take -3 times all of those terms. So that says -3x squared plus 18x minus 27. Then again, the last thing I would do here is see if there's any like terms. So x to the third, I don't see any other x to the thirds, so that's going to be by itself. Now negative 6x squared and negative 3x squared, what would that be together? Good, so negative 9x squared. Your x's, what would be 9x plus 18x? Good, 27x. And then last would be that minus 27, because there's no other numbers. Lastly, here we have division. So we're taking g divided by h. So we were multiplying on that number 3. Now we're going to do the opposite. So we're going to take x squared minus 6x plus 9. And we're going to divide by x minus 3. So this is when you're going to, since you've got something with an x squared, you're going to want to try to factor that on the top. So what are two numbers that multiply to 9 and add to a negative 6? Good, so x minus 3 is how this factors. What can we cancel off? Good, you got an x minus 3 on the top and x minus 3 on the bottom, so you can reduce that by canceling them. And so you're left with x minus 3. So again, that's similar to what we did back in chapter 5 when we were working with those rational expressions.